Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll evaluate limits for expressions with absolute value function. As per the problem, evaluate these limits using one-sided limits. We have to evaluate these two limits by evaluating their left-hand limit and right-hand limit. Let's start with the first limit. Limit x approaches 5, absolute value of x minus 5 over x minus 5. Before we evaluate the left hand and the right hand limits for this expression, we should understand the concept of absolute value function. Absolute value function is a function that makes the value of an expression positive. So if the value of an expression is positive, it stays positive, and if the value of an expression is negative, the absolute value function makes it positive. In the first expression, we have the absolute value function in the numerator for x minus 5. Let's start by analyzing the left-hand limit. For left-hand limit, we should approach 5 from the left side. So we place a small negative sign on 5. In order to evaluate the limits, we have to get rid of the absolute value function in the numerator. Since we are calculating the left-hand limit, that means the value of x will be less than 5 because we are approaching 5 from the left side. As a result, we can rewrite the absolute value for x minus 5 as negative x minus 5. Because if x is less than 5, for example 4.9, then 4.9 minus 5 is equal to negative 0.1. Since the absolute value function always gives us a positive value, we put a negative sign outside x minus 5 because that negative sign will make negative 0.1 positive. This is a very important concept we need to understand and memorize to evaluate limits for expressions with absolute value function. In the denominator, the expression will stay the same. We can simplify this expression by cancelling out the x minus 5 from the numerator and denominator. We are left with negative 1. Since there is no x term in this expression, the value of the left-hand limit is negative 1. This should be the final answer for the left-hand limit. Now we can evaluate the right-hand limit. We should put a small plus sign on 5 for the right-hand limit. We have to get rid of the absolute value function in the numerator. Since we are finding the right-hand limit, we have to approach 5 from the right side. So the value of x will be greater than 5. In that case, the value of the expression x minus 5 will be positive. So we can write the absolute value of x minus 5 as just x minus 5 because the value of this expression will be positive because we are approaching 5 from the right side. That means x value will be greater than 5. The denominator expression will stay the same. Now we can simplify this expression. We can cancel out the x minus 5s. Since there is no x term in this expression, the value of the right-hand limit is equal to 1. We can see that the left-hand limit is not equal to the right-hand limit. Therefore, we can conclude that the limit does not exist or DNE. This should be the final answer for the first limit. Now we can evaluate the second limit. Limit x approaches 5 over 2, absolute value of 2x minus 5 times x plus 1 over 2x minus 5. We have to evaluate the left hand and the right hand limits for this expression. Let's start with the left-hand limit. For left-hand limit, we should put a small negative sign on 5 over 2. We have to get rid of the absolute value function in the numerator. We are calculating the left-hand limit. That means we approach 5 over 2 from the left side. So the value of x will be less than 5 over 2 or 2.5. If we sub in x as 2.4, we get a negative value for the expression 2x minus 5. So we can get rid of the absolute value function by putting a negative sign outside 2x minus 5, and we put it in parentheses and get rid of the absolute value function. The other expressions stay the same. Next, we can cancel out the 2x minus 5 from the numerator and denominator. Next, we can apply the limit. We should sub in x as 5 over 2. Five over 2 is equal to 2.5. The left-hand limit is equal to negative 3.5. Now we can evaluate the right-hand limit. We should put a small plus sign on 5 over 2. We have to get rid of the absolute value function in the numerator. Since we are calculating the right-hand limit, we are approaching 5 over 2 from the right side. On the right side of 5 over 2, x value should be greater than 5 over 2 or 2.5. If we sub in an x value greater than 2.5 in the expression 2x minus 5, for example 2.6, I get positive 0.2. So we can change absolute value of 2x minus 5 to just 2x minus 5 in parentheses. The rest of the expression stays the same. We can cancel out 2x minus 5 from the numerator and denominator. Now we can apply the limit. We should sub in x as 5 over 2. I get positive 3.5. So we can see that the left-hand limit is not equal to the right-hand limit. Therefore, we can conclude that this limit does not exist. This should be the final answer for the second limit. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.